Hi, so today we are going to talk about polytomous regression. For reference, I am going to use the chapter 8 of applied logistic regression. So generally speaking, when we are using a logistic regression, we have two different outcome levels, and generally speaking, when we have more than two levels of the outcome, we use a generalized version of the logistic regression, which is known as multinomial regression. And this multinomial regression is also known as polytomous logistic regression in various textbooks. When we had only two labels of the outcome, it did not really matter whether that variable is a nominal variable or an ordinal variable, because we simply would list one of those labels as reference level. So everything we would interpret would be the comparison between the reference level compared to the other level. But when we have more than two levels of the outcome, then it matters whether it is a nominal scale outcome variable or ordinal scale. What is nominal scale? Say for example, colors could be example of nominal scale: red, white, blue. On the other hand, ordinal scale means that the labels can be ordered. Say for example, you can have low income group, middle income group, and high income group, and these can be ordered. These are not nominal. So depending on which scale of measurement we have for the outcome, we have to use two different types of regression. So when we have this nominal scale, then we generally use this multinomial or polytomous type of regression. When we have this ordinal scale, then we have to use something different that I will hint at the very end of this talk. So for today, in this particular discussion, we are basically working with this nominal scale. And for today's data, we are going to use a particular data set known as the APS data, which was particularly used in this 2008 paper. And this example was explained in the chapter 8 of the textbook that I have mentioned earlier. And in that APS data, the outcome is placement of the subject. And this placement was possible in three different ways. The reference level was the outpatient or day treatment, which is labeled as out day. The second label was the intermediate residential, which was labeled as int, and the residential was labeled as res. So these are the labels of the outcome, and the variable that we were using was the place 3 variable. And see, we have three different levels of the outcome. So we can have this one, the first one, as the reference level, but still we have two other levels. So if you look at the data set, you can see by looking at the first 5 observations, you can see out day and res is there. But if you look at more observations, you will see there would be another label such as int. And this particular data set that I'm showing here is known as the APS data, as I have mentioned earlier. And this data set is available in the Aplore 3 package, which comes with the textbook that we are following today. So if we table the place 3 variable, which is our outcome, we can see the frequency of the labels. So these are the 3 labels we are working with today. Note that in here we are not really saying that this is a ordinal variable. This is considered as a nominal variable for this particular example. Alright, so if we have place 3 as our outcome, we have a number of independent variable, and one of the variable we have is history of violence. So what we are doing here is we are basically cross-tabulating the history of violence variable with the outcome variable. And the history of violence variable is a binary variable, and the outcome variable was place 3, where day or outpatient was the reference category, and the other categories were intermediate residential or residential. So from this cross tabulation, we can basically calculate the crude odds ratio very simply. We are basically using the AD by BC rule. So how are we calculating this? Say for example, if we are dealing with residential versus the day or outpatient, so we are basically using this 80, 179, 15 and 104 for calculating the residential, and we can simply use the 80, 179, 26 and 104 to calculate the comparison between the 1 versus 0, like here. So we can basically calculate the both crude odds ratio in this way, and this is just a generalization of the 2 by 2 table that we used to use to calculate the two binary variables odds ratio. In here we are basically extending that formula into and making it two odds ratios, where we are keeping the reference level same. Only thing that is changing is the other category for which we are changing the odds ratios. Alright, so we can basically calculate the same odds ratio just by restricting our analysis, so that, say for example, in here we are subsetting the APC dataset where the place 3 variable does not have any residential subjects. We only have the outpatient and intermediate residential. We do not have any residential subjects here, and the odds ratio is 1.79. Remember, our previous odds ratio was also 1.79. And in here what we are doing is that we are simply ignoring the int. So int was the level 1, so we are comparing level 0 and level 2 here, and that will give us the odds ratio of 3.10 when we are rounding up these numbers, and that is basically coming from this odds ratio calculation. So calculating the odds ratio is not really the big deal. We can simply calculate the odds ratios from the tables, but when we are subsetting the dataset in this way, where we are basically deleting subjects for one particular category, then the confidence interval that we are getting out of these regressions are not going to be the most reliable confidence interval. So one of the nice feature about this multinomial model fit is that you can basically use the multinorm function from the nnet package to run the same regression but without any subcategorization or subsetting, and that will give you almost the same odds ratio, but the confidence intervals will be something that will be more appropriate compared to the subsetting and running logistic regression twice. So when we have more than two categories in the outcome, in that case multinomial model is going to give us not only the correct odds ratio but also the correct confidence interval. Alright, even though the odds ratios are going to be the same when you calculate it using the logistic regression, but the only reason we are going to do this multinomial fit is basically for the confidence interval. Alright, so so far we have just talked about whether to use this one variable, viol, or the violence variable, history of violence variable, but we definitely want to check whether this violence variable is significantly contributing to the model to justify this modeling. To do that, we can simply fit two models, one model with the viol variable and another model without any covariate. So you are basically using one here to model so that you do not have any covariate in the model, and you name it fit 0 and you compare this fit and fit 0, and then you can see the p-value for the chi-square test is going to be very low. That means that these two models are very different, and that means what? That means that this fit 1, when you are including this viol variable, that is significantly contributing to the model. So far we have discussed what happens when you have a nominal level of scale for the multi-category outcome. We basically use the Polytomous regression, but when we have these labels that can be ordered, then you basically use the ordinal logistic regression or the ordinal regression, which can be fitted using the polar function from the mass package. So in the lab we will see an example using this polar function. Thank you.